polynomials and end behavior. So the good news is if you are required to graph any of these today, you're basically just going to be doing sketches. So when I look for a sketch, like to give you guys full credit, the x-intercept, so where it crosses the x-axis, you'll have to find those, which I'll show you guys how to do. Like direction of the graph. Okay, so when it says end behavior, they're talking about like what's it doing as you go to like the negative infinity side, and what's it doing as you go to the positive infinity side. So both of these would be considered, what are both of those doing? They're going up. They're increasing the whole time, right? How about this one over here? Like this one's decreasing, that's going down, and then this end is going up. So one thing I want to point out to you is the highest exponent is a 4. That's an even number, right? And this one over here, the highest exponent is a 5, which is an odd number. Notice what's happening. When they were even exponents, right? They were both going up. And when it's an odd exponent, they were doing different things. One was going up, one was going down. Single time. Okay, so that's something, and it's further in the notes, so you don't even have to write that down, but you guys will see it again. I just want you starting to like think about that right now. So as you look down here at the bottom, we've got 3 graphs. We have their equations here. So we're going to talk about what's happening as x goes to the left, like the further to the happening to the y. It's going down. So you guys would put y is going to negative infinity. Yeah, you guys are going to be drawing. So as our graph moved to the left, as the x value decreased, the y value decreased. Okay? It should be as x goes to positive infinity, so as x is increasing, what's happening to y? It's also increasing. So the y is going towards positive infinity also. So you might want to make a note here. This one went to negative infinity. This one went to positive infinity because it was going up. And then just one more thing I want to point out with that one. So when you guys are done filling that out, look up at the screen, please. My x odds, they should go different directions, right? You should have an up and a down. Did we have an up and a down? Yeah. Okay, in the middle. As x goes towards the left, meaning as it decreases, what's happening to the y for the most part? I mean, obviously you see how does the end go? Goes towards the positive infinity, right? Okay, and that's because it's going up. And as x increases, so as we move to the right, what is y doing? It's also going up. So that one's going to positive infinity. Just make these notes on here. Just so you guys know, like when I say x is approaching negative infinity, I mean as you go to the left. And as it approaches positive. Okay. And if you look at the equation of the one in the middle, it had an even exponent as the highest exponent. The direction should be going the same, right? They're either both going to be going up or they're both going to be going down. It just depends on what the picture looks like, but they should always match. Exponents should match directions. Odd should be opposite. That's a good way to remember odd, opposite. Okay, I just gave you the function. If I didn't even give you this picture, you guys should be able to at least tell me that because the highest exponent's odd, the ends should be doing opposite things, okay? But now with the picture, as we move to the left, what is this end doing? It's going down, so the y approaches negative. And then as we move to the right, goes up. It approaches positive infinity as well. All right, we okay with that? As soon as you have all that written down, go ahead and turn the page. To show you the odds versus the evens, which, I mean, I've already talked about already in our notes, but we're going to just do more of it. Okay, I'm going to just do this. You might want to just... The two top ones are odd degrees, meaning the highest exponent is odd, and the bottom ones are even. You guys know, I don't know, like a linear equation. If the number out front was positive, what typically happens? It was a positive slope, right? And if you think about positive slope, doesn't that mean, if you guys were looking at it, it's doing this, right? It increases. So the left side is down and the right side is up. Okay, well with our odd exponents, if there's a positive number out front, like in this case, it should kind of be similar to that positive slope of a line, meaning this. The left side of our graph should be, whereas the right side of our graph should be approaching positive infinity. Is that what's happening here? Mm-hmm. Yeah, the left side as x goes to negative infinity because it's going down. And then as x approaches positive infinity, y also approaches positive. So a positive, I'm going to make this note up here, positive leading coefficient. You guys might want to look. Even though it's going to be a curve, it should still kind of be similar to what the left side should be the negative, should be lower, decreasing. The right side should be positive. So if it has a positive leading coefficient, so decrease on the left, increase on the right. That's what the two ends should do. Just like it did with a straight line, or with a diagonal line. Okay, now if you look at the one underneath it, odd degrees doing different things when they're odd. One should be going up, one should be going down. But look at the leading coefficient this time. Leading coefficient is negative. Doesn't a negative linear equation typically do this? It starts higher and ends lower. So it's basically the same thing. If there's a negative out front, the left side as x goes towards the negative infinity, y should be going. Yep. Yep. And then as x approaches positive infinity, the y approaches going down. Good. So, one more note to make on there. We're going to write it over here. Odd go opposite directions. You should always have one up, one down. And then at the bottom, we're going to make notes about degrees. They should be going the same direction. What do you think the leading coefficient would be if they're both going up? Would it be positive, down, negative? This one's a little bit easier to understand, I think. So with our even degrees, if there's a positive leading coefficient, ends should be going up. So what should both of these say for y? If they're both going up, they should both approach what? Positive infinity. Yep. And then the negative leading coefficient is just going to be the opposite. Negative leading coefficient, our ends should go down. Both of our y's should be approaching what kind of infinity?
Negative.
Negative infinity. You guys will be pros at drawing those infinity symbols by the end of this. And then I'm going to make the note in the middle here, just like I did up top. I'm going to put that the E go same direction. And then whenever you're ready, go to the next page. So now they're going to give us pictures, and they're not telling us what the function is. They're not giving us the equation. So we are going to look at the picture and figure out whether the leading coefficient's positive or negative, and then whether the degree is even. Opposite directions, is that even or odd? That's odd. Okay? And when they're odd, decreasing over here, increasing over here. Does that look more like a positive slope or a negative slope? So that goes along with the leading coefficient. Leading coefficient has to be positive because the left side is decreasing, the right side is increasing. So the y on the left side approaches what? Negative infinity because it's going up. Positive infinity because it's going up. Okay? Then the second one. These are going up. So it doesn't really matter. If it's same direction, is that even or odd? Even. And if they're both going up, positive. Up, what should both of these say? Goes, yep, y approaches positive infinity. Okay, next one. Looks like they're going opposite directions this time. So opposite directions means odd. So it's an odd. We've got it increasing on the left, decreasing on the right. So if I were to put my pen here for a slope, which means it would be negative leading coefficient. So as we move, goes up, so that's positive infinity. And then as we move to the right, what does y do? Negative infinity. Yep. Because symbol. My right side always looks better than the left side. Same directions, even or odd? They're both going up. So both of them should say y approaches positive.
My right one always looks better than my left one to me.
I know. Well, that's because we start with the one's more symmetrical, right? The left side just looks like trash. That's okay. It's just a symbol. I know what it is. Everything we've done so far, the characteristics of these graphs, I don't think are all that bad. When you turn the page, now we're going to actually do some sketching. These are the things you need to know. We need to know the degree. So if it's odd, what's true about the ends? If it's odd, they're opposite, right? Odds are opposite. So I'm going to just make that note here. Okay, so I know that later on, when I actually go to do this sketch, I should have one side increasing and one side decreasing. So if it's positive, does it go decrease on the left to increase on the right, or no, it should, the left side should decrease and the right side should increase. This picture will end up looking like. That's all I know so far. But in order to actually graph this, we need to know where it's going to cross the x-axis. This goes along with what we did yesterday. Remember that factoring we did yesterday? What do these three have in common? They just have an x in common, right? So we're going to factor out the GCF, and if you bring an x out, x squared minus 6x minus, we'll just minus 7. So what we need to do now is we need to factor the inside. That's an asterisk problem. So those of you that weren't here lesson, I would give them a function like this. We'd factor out the GCF, and then we'd make an asterisk for this. We're going to end up getting 3. Potentially, you could have 3 different x-intercepts, and that's what we're going to get here. Okay, so the -7 is up top, the -6 on the bottom. Well, there's only 2 numbers that multiply to make 7. It's 1 and 7, and then the 1's the positive. So we've got our 2 sets of parentheses now. I'd write 0 equals x, and then our 2 x plus 1 and x minus 7. Most of you are really good at going. Those of you that weren't here yesterday, I know you guys can do these 2, and I'll talk about the one out front here in just a second. But if okay, so x would be -1. This one here, x would be +7. Hanging out here by itself, if that were just a number like 2, that would not be one of our x-intercepts, but because there's up front has to be set equal to 0. Well, wouldn't that just say x equals 0? Yeah, there's your third x-intercept. Okay, now, because we said this over here, what, positive or negative? Negative infinity, and then the right side should approach positive infinity. Okay, we have everything we need to make this positive, because remember, they go opposite directions. So the left side should be decreasing, the right side we said was increasing. So this is what you guys get to do now. You are going to put a dot at these 3 numbers on the x-axis. So I'd have 1 at 0, +7, all I know is this. I know I'm going to start down here and I'm going to end up here, right? That's what we said. Now it has this one, go up a little bit, turn back around, come down, turn back around and go up. Do we really know how tall it's going to be? It doesn't have to be exact. That's the whole point of using the term sketch. So just watch. I mean, this isn't going to be great. Like I said, I'm just sketching here. All I want you guys to do is around and then go back up. I mean, I don't know if this little piece here and this piece here, I just know what I'm going to be looking for on yours is, do you have the 3 correct x-intercepts and did you go the correct direction? So you guys would get full credit for that. Even if you made this one up here, if you guys made this one taller than mine, you'd still get credit as long as it's going the right direction and you crossed all 3 of those points. You guys okay with that?
Is this all we're doing today?
And then a review for the test. But this is the only lesson. This is the last lesson of the unit.
Next lesson's easier, right?
This is the last one.
No, I'm saying next lesson that we have is easier.
I have No idea. I haven't even looked at it yet. I go day by day in here. Well, 2 days at a time, really. All right, so then this last, it is odd again. So we know they're going to be opposite directions. However, if we go low to high or high to low? High to low. Okay, so we know high over here, low over here, because they're opposite and the leading coefficient was negative. So now look, do we ever want there to be a negative out front?
No.
Like if you had to do the asterisk, we never did that. Instead of bringing out, like, what do they all have in common? Don't they all have an x in common? Well, instead of just bringing out positive x, why don't we bring out a negative x, and that'll get, because if you take negative x cubed divided by negative x, isn't that now positive x squared? X squared. If there's ever a negative out front, I take it out. I don't like it. Okay, and then what's going to happen here in the middle? Instead of being negative 2x, and then instead of positive 8, negative 8. And then this whole thing. Now you guys can do an asterisk for this. Numbers multiply to give us negative 8, the add to give you negative 2.
Negative.
Negative 4 and positive 2. So I still have that negative x out front, but then I'm going to have my two sets of parentheses. I'm going to have x minus 4 and x plus 2. We've got these two, and anytime, whether this is positive x, negative x, 2x, 3x, negative 4x, that one is always going to equal 0. Anytime you have some, what's this one going to equal? Positive 4, and then this one here, negative 2. Steps. And then we already said on the left side of our graph, the y should be infinity. And then we said on the right side of the graph, it should be low, meaning the y should approach negative infinity. Have 0, 4, and negative 2. Those are your three x-intercepts. Up here somewhere. You want to start up, come down, and curve around to hit all 3 points. And then just end down. So they are going opposite directions. It's going high to low, And we have our 3 points that and I think that's the end of our notes, right? Yep. Is everybody good? So that's the end on next. And then, like I said, during fourth period, we're going to work on the Unit 3 test review.